Hello friends, today we are going to see about time series problem and non-time series problem. First we can see about non-time series problem. For non-time series problem, let us take the regression algorithm. Um, um, as an example, we have a data that contain AC sales, AC sales and month. So we need to develop a model that can predict um, sales depending upon month. Let's take month on x-axis and sales on y-axis. Let's plot the data. In x-axis, there is month, Jan, Feb, like that. So whenever after training the model, it form a regression line like this. Regression line like this. So whenever you're trying to find find sales depending upon some month, we will draw a line over here and we can find out the sales at the month uh, at that month. But here the sales of each month does not depend upon the other month. This is called as non-time series problem. It just um, it just the sales is depend upon each month. That sales does not depend upon the current month, does not depend upon the previous or the previous month. This kind of here in this use cases we have used a time period, but that time period that does not each time period does not depend upon the um, another time period. This kind of problems is called as non-time series problem. But let's take another example for a time series problem. We have here data that contain time period and in y-axis stock value. In y-axis there is a time period, the chart uh, stock price on y-axis. Whenever you plotting this can be like this, it can be like this. This each time period is depend upon let's take this time period. Let's take this time period. This time period is depend upon the previous time period. Let's take the current time period is t. uh, this time period, let's take it as T. So we need to predict that what will be the um, stock price at the time of T. That can be decided by the previous time. Um, let's split this time in a specific limit, specific limit like this, and this this time period is take as t minus 1. This time zone is taken as t minus 2. This time period taken as t minus 3. This in between these two time period, each two time period, we can say that as lag. Let's take it was the current time period. Before 1 lakh, what will be the output, and before 2 lakh, what will be output, before 3 lakh, what will be output. So depending upon the previous time period, we can find what was the value for the what was the price of the stock for the current time period. This time period algorithm are specifically handle the data where temporal orders matter. For this time series data, temporal ordering is matter. So we order the time period in a increasing form. There is an order is present here, and will be split each time zone in between each of the time zone. For example, t minus 1 t, there is an time gap. The same time gap will be present in between t2 and t1. Like this, we want to split the each time period. Uh, for time series for time series algorithm, for time series prediction, there are some of statistical methods are there, like ARIMA, yes, ARIMA, and expon, expo, exponential smoothing are there. These three are the most popular time series algorithm in machine learning. This ARIMA is called as auto regression integrated moving average. Um, that means combine auto regression and differencing and moving average component. This kind of model is ARIMA model is um, suitable for univariate time series problem. This kind of ARIMA model is very useful in univariant data set. Um, the season um, that does not have a seasonality. Whenever we handling a season based problem, we can go to yes ARIMA. That means Seasonal ARIMA. So there is another model is exponential smoothing. This model this model is level will analyze level, trend, and seasonal component using some exponential smoothing technique. Um, smoothing technique. There is some key points that we should consider whenever we talking about a time series problem, like stationary. Many algorithms assume the data is stationary, and they differencing and detrending are common technique to achieve stationarism. But in a but in a seasonality seasonality problems, uh, seasonal decomposition technique help in understanding the seasonal pattern. There is a concept of seasonal decomposition. This kind of technique is used to pattern, understand the pattern in time series problem, understand pattern in time series problem. And there is a lag feature. Lag feature means um, we need to create a lag version of original series, and that can capture temporal dependencies. For example, we to find a lag. Uh, this distance, the present time and the previous time, there will be an time gap. This time gap is called as lag. So we need to create a lag version for the time series, for the original time series, to capture the temporal temporal dependency. By creating this time gap, we can find temporal dependency. So depending upon this, we can we can we can find we can predict stock price of any of the time period. And there is also another technique that was used in time series problem, that was windowing. The windowing means this is the overall time period. Let's take some portion of time period. This time period, uh, the windows method first initially go to this time period, and and analyze the pattern, and then let's go to one step forward and analyze this time period, and then move forward little bit. Like this, the windows function takes some portion of time period and also consider the previous time period in consider the previous time period, and analyze the pattern of every time period, and then it will be predict the time based problem. depending upon the previous experience. The each algorithm has a strength and weakness, and choosing of an algorithm often depends on the specific characteristics of time series data and the problem that we handled. Um, so we need to initially understand that what was the problem for this problem, what kind of things should consider, and then to solve this, what kind of technique that can be used. So we need to prepare a plan for that, and then we should and we will move on further. So for a time series problem, it's very important is we should consider the previous time period. Whenever we increasing at previous time period, and we by windowing the range of time period. So by using that kind of technique, we can easily understand the pattern of time series problem, because we all see normal algorithms, non-time series algorithms, when compared to non-time series problem. A time series problem is very important, and it was so complicated to understand. This is the basic basic algorithms that are used in building ML models whenever there is any time series problem which we have. Okay, let's Arima will take care. It mostly used in forecasting the sales of stock price. We all know that in stock market, the stock price of a stock will be depending upon the time and the season. In these kind of time series algorithms like Arima, the the models are assembled in a linear relationship, and they are not well suitable for handling complex seasonality or multivariant data. These kind of time series problem to be stationary and made stationary to the differencing. This Riemann exponent smoothing, smoothing, smoothing. Uh, it uses the time period to make the predictions. Arima is a powerful time series algorithm. We can see it on tomorrow. This kind of this time series problem is especially used in forecasting, and it will uses auto regression moving average component to ensuring the stationarity. We need to ensure the stationarity. there are some to train this ARIMA model. It has some it does need some components like auto regression and integrated part and moving average. By using this kind of technique, is moving average will uses the window slide function over data to analyze the pattern. Unlike to ensure the order order of a time series, the time series should become one by one after another, like that. To ensure that, we use integrated part that consider the statistical properties of a time series and do not change over the time. In order to differentiate the needs to achieve the stationarity, we use first order referencing and moving average to calculate the to predict the time series problem. Okay, we can see ARIMA and ARIMA algorithm on next upcoming. Thank you.